Alright, ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of May 16th, 2018, and we're looking at Math 8 Enrichment. This is multiplying and dividing terms with exponents. Let's get started. Alright, so as a friendly reminder, the following information is what you need to know for the SOL as far as exponents are concerned. So any number to the first power is itself. So 3 to the first power is 3, 4 to the first power is 4, 234, which I just picked out of the air, to the first power is 234, and so on and so forth. Now, any number to the 0th power is 1, except 0, that's an exception. 2 to the 0 power is 1, 5 to the 0 power is 1, 1010 to the 0 power is 1, which is another number I just picked at random, and so on and so forth. The only exception to the 0 power rule is 0 itself. 0 to the 0 is what we call undefined because of the way mathematicians define exponents. And you'll learn a lot more about that when you get to algebra. Now, this is what you need to know for the SOL, but this is enrichment. Multiplying and dividing terms with exponents. So you'll see more of that when you get to algebra, and the purpose of homework at this point in the year is to kind of give you a taste of what you're going to get next year. So this part won't be on the SOL, but I do want y'all to kind of work with me on this. So part 1 is multiplying exponents, and if you watch this problem, you'll see 27 times 9 is 243. That's just a regular old problem. I'm going to write it in a different way. 27 is 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. If you take that and multiply it by 9, which is 3 times 3, you still get 243. Now, here's another way to write this problem. 3 to the 3rd power, which is 27, times 3 to the 2nd power, 9, equals 3 to the 5th power, which happens to be 243. Here's what we know about this. Our base is 3, and our exponents, though, 3 to the 3rd and 3 to the 2nd, our exponents are 3 and 2. Add them up, you get 5. And it works out that way anytime you have numbers and you have to multiply their exponents. So when you're multiplying terms with exponents, you add the exponents to find your answer. And it's like I said, it's really convenient that numbers work out like that. So let's go on and look at dividing exponents. Here's part 2. Now, this is 27 divided by 9, and if you do that in the calculator, you get 3. I'm going to write it in a slightly different way. 3 times 3 times 3 divided by 3 times 3 equals 3. Alright, so 27 is still your top number. 3 times 3 is 9, 9 times 3 is 27, 3 times 3 is 9. So 27 divided by 9 is 3. Another way to write this problem, 3 to the 3rd power divided by 3 to the 2nd power is 3 to the 1st power. Are you all seeing the pattern? Our base stays the same. Our base is still 3. But now we subtract our exponents. 3 minus 2 equals 1. And that's 3 to the 1st power, or just 3. So when you're dividing, you subtract your exponents to find your answer. All right? Let's go through a couple of problems. So here's number 10. Negative x times negative 6x cubed. How do we simplify that? So negative 1 times negative 6 is 6. You're still doing the multiply when you're talking about the regular constants, the regular coefficients. So negative 1x times negative 6 is positive 6. The base is x, that stays the same. And then 1, which we don't write, 1 plus 3 is 4. All right? So we get 6x to the 4th power. I'm going to show that to you one more time. So we have negative x times negative 6x cubed. Now here's the parts that we don't actually write in. The ones are understood. So that's negative 1x to the 1st power and negative 6x cubed. So here's the parts. We don't write our ones, but we just know that they're there, okay? Now we multiply our negative 1 and negative 6, we get positive 6. The bases we just keep the same. And our exponents, 1 plus 3 is 4. So again, we get 6x to the 4th power. All right, let's look at our next one. 3x squared times 2x to the 5th power. 3 times 2 is 6. Our base stays the same, that's x. and 2 plus 5 is 7. So again, 2 plus 5 is 7. So we get 6x to the 7th power. All right, moving on to number 12. Negative 6 times negative 2 is positive 12. Our base is y, that doesn't change. And 2 plus 5, again, is 7. So we get 12y to the 7th power. And now we're going on to division. And because these problems are a little simpler, all our coefficients are 1, so we don't have to worry about dividing coefficients. If we had a coefficient here, we would treat it the same way. Like, let's say we had 6x to the 11th power divided by 3x squared. We'd end up with 6 divided by 3. Our new coefficient would be 2. But don't worry about that because we don't have any coefficients that way. So x stays the same, and 11 minus 2 is 9. This one is just x to the 9th. And you could say 1 divided by 1 is 1x to the 9th, but we don't need to write it down. Number 14. A is our base. That stays the same. And 6 minus 3 is 3. A to the 3rd power. All right, and again, 1a6 divided by 1a to the 3rd. 1 divided by 1 is still 1. So again, we don't need to write that 1 in front of the a. And the last part here is 7, and that's our base, even though it's not an alphabet. 7 is still our base, and that doesn't change. 9 minus 6 is 3, so we get 7 to the 3rd power. All right, and that is it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.